This is a talk by Christian Ebert, Balthasar Bickel, and Paul Widmer from Zurich. And so Christian is presenting, and he'll talk about word order variation in Baltic, Slavic, Germanic, and Romance, please.
Yeah, thank you very much for the introduction. I'm going to present a corpus study on word order variation. And in this talk, we want to we are going to propose a usage-based account of word order variation on a sentence level instead of focusing on canonical word order. We want to quantify the influence of two factors that drive the diversity of word order. One is the divergence over time of related languages, or on the other hand, the preservation of inherited similarity, the so-called phylogenetic signal. And on the other hand, of course, there's areal convergence of languages that are spoken close to each other. And the impact of these factors on word order variation in modern Indo-European languages will be investigated by quantitative methods that add together for a more complete picture. We used a sample of Indo-European languages that are spoken in Europe of the four larger branches. In total, we have we tried to include all the languages that we could get, and we ended up with 8 languages of the Slavic branch, the 2 Baltic languages, 5 Romance languages, and 6 Germanic languages. And yeah, on the left you can see a phylogenetic tree, on the right the distribution of languages over space in Europe. And yeah, it's easy to spot that most of the languages that are related are also close to each other in space, and maybe with the exception of Romanian, which is surrounded by Slavic languages. As a corpus, we used the party corpus from Natalia, and we added a few subtitles for languages and some films with a good coverage of languages that we were interested in. So at the moment, we extended the corpus to 20 films with a total of 30,000 sentences. And for the syntactic annotation, we used the Python model called Spacey and trained the models with 30 languages with universal dependency tree banks. Just a few words on the advantages of subtitles. As opposed to other types of parallel corpora. While there are many more parallel texts by design, such as parliament debates or the Bible, subtitles have the advantage of being close to spoken language and a bit more colloquial in style. And you also get a large variety of different speech acts, pragmatic contexts, and so on. While not all of the social linguistic diversity of the movie audio makes its way into the subtitle, subtitles still follow orthographic rules. For example, the choice of specific constructions and lexeme that might be typical for colloquial language is usually not omitted in subtitles, so we can still get a bit of variation. And now to move on to actual data. Out of those 30,000 sentences that the corpus has, we only used 3,700 sentences. We filtered out short sentences with fewer than 3 constituents, and of course sentences without a finite verb. Also, we needed, of course, parallel sentences to compare with. So for a given sentence, at least 10 parallel sentences in other languages should satisfy these criteria of being long enough and having a finite verb too. And each sentence was classified in a 3-way distinction, either verb initial, verb medial, or verb final. And this distinction is basically based on the surface structure and the location of the finite verb. So out of the table with parallel sentences, we calculated adjusted mutual information score between each language pair. Adjusted mutual information is a measure based on entropy with an adjustment for chance. So mutual information between two variables is basically the amount of shared information or predictability. If the mutual information is low, variables are independent, and on the other side, if mutual information is high, there's some sort of correlation. And in order to use it as a distance measure, it needs to be normalized and, in our case, adjusted for chance. Also, in order to get a more even spread of the scores across the whole range from 0 to 1, we scaled it by the highest observed mutual information score in the sample. And these scores we used for creating a distance matrix, which we used for the following procedures. First, we used NeighborNet for visualization. This is more explanatory investigation. Then the next step was we ran a fuzzy C-means clustering algorithm to examine if there are any clusters in the syntactic data. And finally, we combined the syntactic distance matrix with spatial and phylogenetic data and ran a variation partitioning analysis. So here you see the NeighborNet plot. So distances between languages are represented as lines, and the length of the line connecting two tips indicates the degree of dissimilarity between languages. So if there's a longer line, it means that languages are more distinct from each other. And languages that are more similar to each other clustered together in those branches. And in this case, we get a fairly tree-like structure, which is also indicated by the delta scores and Q residuals. We get 4 main branches that match more or less established phylogenetic groupings. So if we start from the southeast, we see Germanic languages. Then to the left, we see this one branch consisting of West Slavic and South Slavic languages with a more or less pronounced split in between. Then on the top, we see Russian, Ukrainian, which means the East Slavic languages, and Lithuanian and Latvian, the Baltic languages, in one cluster. And the last cluster is right next to them, which is the Romance languages, with only French missing, and French is situated right in between the Romance and the Germanic cluster. So now to move on to the next procedure, which is the fuzzy clustering. So the objective of C-means is basically like many other clustering algorithms. It's about finding the optimal solution for a given number of clusters in the data. What is specific about fuzzy C-means is that it does not return hard clustering like K-means, for example, but it returns fuzzy clusters where membership is gradual, measured by a membership coefficient. So each language is basically assigned to each of the clusters, but with a different membership coefficient, which are then ranked. And yeah. So every language belongs to each cluster to a certain degree. To find the best number of clusters, we used a simple elbow plot, which you can see on the bottom of the page. It's not really pronounced bends, but we can see a slight bend around around 4 clusters. So the increase of the coefficient slows down after 4, which means that 4 is probably the most economical choice of clusters. And yeah, and adding more clusters would probably not improve our results. So we went for 4 clusters, which you can see here. The intensity of the color indicates the membership coefficient. Like the really bright languages are those with a high membership coefficient for one of the clusters. And the lower it gets, the more it goes into a shady grayish area. And so cluster 1 is easy to see that those are like the 4 Romance languages without French. French is in the grayish area, which means it has a quite low membership coefficient and it's not assigned to this cluster with high probability. In cluster 2, you see like the core of Slovak and Czech, which are almost like 100% surely assigned to this cluster. And then the large distance, there's Croatian and Polish, and further down also the other South Slavic languages. Then cluster 3 is Germanic only. And cluster number 4 is East Slavic and Baltic. So French again, if you have a look at, you can see French at the bottom of cluster 2 and cluster 3 as well, with at least for cluster 3 quite high membership coefficient, which means French is almost equiproportionally assigned to cluster 1 or cluster 3. So it's like in the neighborhood, it's basically right in between Germanic and Romance. It's also noteworthy that the membership coefficients for Bulgarian and Slovenian in cluster 2 are actually only slightly higher than in cluster 1. No, actually, they are low in, they are assigned to cluster 1 because their membership coefficients are higher than cluster 2. But they are also like almost equiproportionally, so it's not really a clear distinction. Also, if we have a look at cluster 4, there we can also see Bulgarian with a membership coefficient of 0.25. So there seems to be some fussiness here. So if we plot those membership coefficients to a map with a similar procedure, like the bright color indicates the core of the cluster, and the more the color fades, the lower is the membership coefficient. So now we can also see that like most of the languages that cluster together are actually geographically close to each other. Apart maybe from the first cluster, the Romance languages, which are a bit spread, and also since French has quite a low membership coefficient, it basically interrupts the connection between Spanish, Portuguese, and Italian. So this is a quite widespread cluster, but for Czech and Slovak, they are right next to each other. Also, the Germanic languages cover a larger area, but also close to each other, and same for Baltic and East Slavic languages. So, to sum up the results of the fuzzy clustering, we see that there's overall a good alignment of clusters and genealogical groupings, but it's noteworthy that Slavic is split into East Slavic opposed to the rest, and also the assignment of the South Slavic languages is not really clear, and also French again is kind of an outlier. So now we move on to the next procedure, which is variation partitioning. The objective is basically we have one distance matrix, and we have two predicting or constraining matrices. And now, like, the variation matrix is constrained or conditioned on the other matrices. So we see, so it allows us to compare the variation in the different fractions that are assigned to each of the predictors, or both of the predictors, and of course there are some residuals or unexplainable variation. So in the end we get 4 fractions, or 3 fractions if we count residuals. And for the geographic distances, we used, we used the language polygons from Ethnologue, and ran 1,000 samples of random points taken from each polygon. Then distances were calculated, and the dimensions of those distance matrices were used by a distance-based Moran's eigenvector analysis, which allows us to retain only 80% of the variation, but it also allows us to reduce the vectors a lot. And similar procedure was done for phylogenetic distances. We also have 1,000 trees sampled from the posterior tree from Chang et al., which is a phylogenetic reconstruction of Indo-European. And then we also ran a principal coordinate analysis to reduce the dimensions. And here's a nice workflow, if it's a bit confusing, to see how parallel the workflow actually is. So we have our data collection, and in the next step, we calculate a distance matrix. For syntax, we've adjusted mutual information. For phylogeny, it's cophonetic distances. For area, it's spatial neighborhood. And then we reduce the dimensions with either principal coordinate analysis or distance-based Moran eigenvector map. And those vectors, in the end, all feed into the variation partitioning, which gives us a set of 1,000 iterations of variation partitioning. And now we examine the final distribution of those predictors. In total, that's the gray area to the right. We see that around, in the range between 43 and 69% variation can be explained by the predictors with a mean of 54%. We can see that phylogenetic signal alone explains more variation than spatial distance. Phylogenetic signal has a mean of 20% of variation explained, as opposed to spatial distance, where we have a mean of 8%, which means 8% of the variation could be explained by geography alone. But there's also like this third bluish area, which indicates the variation that is explained by both predictors, which means it can't be distinguished if it belongs to predictor A or predictor B. So this is basically the variation that is found in both matrices, which is the largest proportion, and it has a mean of 26%, and it ranges basically from 4% to 40%. So if we now have a look at the samples, we can see that now we use those random points. So now we only look at those points which really have an impact on variation explained by spatial distance. So we only use the samples that are above a threshold of 2 standard deviations above the mean. And when we examine the distribution of points, in theory, it should be random. So there should be no, there should be an even distribution of points across the polygon. But we can see for some languages that the distribution is not really even. For example, we see that for French, for example, the southern France has far less points than northern France. We can see for Swedish that most of the points are found closer to Norwegian, actually, and the east of Sweden there are almost no points. Same for Ukrainian, we can see that the west of Ukraine there are less points than to the east. So there's some shifts in distribution that can be observed. So to sum up, we'll just give a short synopsis on the different methods and then come to a quick conclusion. So basically in NeighborNet we observed 4 clusters, which is Germanic versus South and West Slavic versus Baltic and East Slavic versus Romance and French. and most of these clusters can be found through fuzzy clustering. Where Germanic is found too, we also found the same Romance group. We find the same distinction from Baltic that goes together with East Slavic. Again, we find that French is kind of an outlier. So yeah, there's these two maps yield roughly the same result. While variation partitioning is not really a clustering approach, so we can't say much about clusters, but we can say that the impact of phylogeny on word order variation is quite high. It's higher than the impact of spatial distance, but still showed that there's evidence for the relevance of spatial proximity, since it explains an additional fraction of variation that phylogeny cannot explain on its own. So, which could indicate that there's some traces of contact or areal convergence. Also, there's a large overlap of phylogenetic and spatial variation. Closely related languages happen to be closer to each other in space too. So it seems to be a problem to disentangle inheritance from areal convergence for these languages. And to sum up, we demonstrated the use of synchronic data for the study of diachronic relations between languages. We highlighted similarities based on synchronic data that might be traced back to a common ancestor. We also found cases where similarities are rather explained by spatial proximity than inheritance. While the actual diachronic development of word order variation cannot be revealed by our approach, we can still single out interesting cases for further investigation. And so now I would say thanks for your attention. Those are the references, and in case you have any questions, I would be happy to take them.
Yeah, thanks a lot, Christian. That's a really cool talk. So let's see, there are some questions there. Okay. So from Petya Arkadiev. So I think I've managed to unmute you, or yes. Oh, no. Just a second. Now it's still. Sorry. Now it should be working.
So,
sorry.
Can you hear me now?
Yes.
Well, thank you very much. It is, well, on the one hand, it is impressive, but on the other hand, I must confess, please do not take it as an offense. I must confess that I'm disappointed, because you have shown us that you are very good at doing maths and doing all these fancy, nice computational things. But I would argue that the linguistic part of your investigation is insufficient. Well, for instance, as far as I understand, you simply looked at the position of the finite verb, whether it's initial, medial, or final. Well, okay, but anybody who knows more than one Germanic language, like you and me, you're a native speaker of German, as far as I can assume, and now I know some German. We both know that English and German are extremely divergent in their word order with respect to the verb, but not with respect to the finite verb. That's a trick. But we all know that word order rules in German, as well as Scandinavian languages, pay quite a lot of attention to non-finite verbs, as well as to embedded clauses. So, of course, it is legitimate to reduce the linguistic data you investigate to well, to the extent you did, but in this case, you certainly lose quite a bit of variation. We all know as linguists that English is not like German in terms of word order, and your investigation has completely missed that. And I see it as a disadvantage. What can you say in response to that? Thank you.
So I'm not sure if I got your question correctly, but I would say that your issue was with that we only looked at like one variable that could be how word order could be described, but of course there are much more variables like yeah, of course we have finite verbs, we have infinite verbs. There are different constructions which we didn't take into account. That's true. So we only looked at one very simple distinction, but we still got a large overlap with estimations of how languages should group together. So this is basically what we demonstrated.
Can I ask maybe a technical question? So you used the universal dependencies and part of speech annotation probably too. And so is it lexical verb, or did you also include auxiliaries? So
we also included auxiliaries.
Oh, okay. Okay. Yeah, so maybe it's more difficult to relate it to, you know, traditional word order typology, because it mostly focuses on lexical verbs, as far as I understand. Okay.
Yeah, so we didn't want to, so we tried to include as many sentences of the corpora that we have, because we took this as a sample of language. And if we would reduce it to only lexical verbs and only finite lexical verbs, the subset of sentences that we take into account would get smaller and smaller and smaller. So this was a methodological decision we made, but of course it's just a small picture of the whole area of word order.
Okay. Maybe a comment from Timothy. It seems logical that French should be between Romance and Germanic, but that it should have such a high score when grouped with Slavic Baltic makes me wonder if there are issues with this method. And confusion of V2 with SVO. So maybe you can read this comment too.
Yes.
Hello, Happy. I'm sorry. To clarify, where I said confusion of V2 with SVO was in relation to the previous question, where we were, you know, discussing perhaps, you know, this issue with English and its relation to other Germanic languages. I was wondering if perhaps it was conflating V2 with SVO, and that this might be part of that issue. And so that comment was really not related to my initial question. My apologies for any sort of confusion there.
Yeah, no, but to say something on the question on the method, I think it was about the fuzzy clustering.
Yes, I'm sorry. I didn't know the exact name of the measure used there.
Yeah, if we have those clusters, as I said, like each language is assigned to each cluster, and then the membership coefficient is calculated. And all these membership coefficients sum up to 1. So if we have like 0.3 in one cluster and 0.3 in the other, there's still like 0.4 of membership coefficient material to go, which is assigned to the other clusters in a way of likelihood. So I don't think that's an issue about the method. It just says, okay, it's fuzzy, but there's still a light tendency to cluster to those two groups where it makes some sort of sense.
Okay, so to follow up on that, given that the Southern Slavic languages that you had, Croatian, Slovenian, did not seem to sort of group with any family in particular, might that justify the creation of a 5th group? Or did you try running the analysis that way? I was just sort of curious about your thoughts on that.
Yes, like if we, I don't know if you have the neighborhood visualization in mind. So there are, of course, there are more possible ways to do the analysis with more clusters, and then I think it would be one cluster would be this distinction between South and West Slavic. Yeah, but I think the way the algorithm works, it prefers like tight clusters around a certain point. So we have, if we have the core of the cluster around Slovak and Czech, then maybe it's harder to distinguish languages that are a bit further away. So I'm not really sure what causes this assignment, but I think yeah, definitely different numbers of clusters would yield different results, which would also make sense linguistically. So we could try this analysis with more clusters and see what happens. But yeah, like the idea behind this method is to use the smallest number of clusters possible. So yeah.
Okay.
Yeah, maybe my suggestion is maybe people who really need a coffee, go get the coffee, and people who are really have very personal questions, if Christian doesn't mind, maybe you can chat and discuss them right now or in the chat, or like maybe we can keep this channel open for everyone who is curious, because I saw a couple of other questions there as well. So please, choice is yours.
I can stay around a bit longer, so if anyone has questions, I'm happy to answer.
Yeah, there was a question from Thomas. Okay, now I have to do this trick and unmute again. Because, yeah, no, it's still not working. Why? Okay, yes, now it's working.
Thomas? Is it working?
Yes, yes, we hear
yes. You. Yeah, because we, you were mentioning the issue of V2 SVO, and the thing is that it's still very striking to find English clustering together with the Germanic languages and still seeing French together with the Germanic languages, because the V2 phenomenon leads to the fact that you have then frequently sentences that are VSO in V2 languages. And this, for example, in the case of German, in the main clause, is the relative frequency of VSO sentences is more than half of the frequency of SVO sentences. And there is no way that English clusters together with this, or French. So there must be some kind of problem in the way the data is stacked. I don't know, maybe it has to do with pronouns and how pronouns relate to the auxiliaries and the finite verbs. Otherwise, I cannot really understand it, because, for example, if we think of sentences with pronouns, in French, for example, we would have an SOV sentence. But do you know how if this was taken into account, or do you only take nominal arguments?
Well, there's definitely one thing about second, we didn't filter for example, for sentences that have like overt subjects and objects. So basically any three constituents would do. Like, it doesn't have to be core arguments, which might lead to a different distribution, because actually, in terms of proportions of the different positions, still English and French would have a high proportion of verb middle, and the Proto-Arab languages would have a lot, like way less verb middle sentence compared to those to English, French, and basically the whole Germanic languages. So I think this is one one issue that causes this distinction that French can't be easily grouped together with the Romance languages.
Sorry, I just got a message from Sari. So because she says that our wonderful sign language interpreters need a break, and so maybe they are. I guess they're tired and need a little bit of time. So maybe we can continue discussion via chat or yeah, maybe by email or other resources. Of course, there many. I have questions too, and I'll get back to you. So okay, then thanks.